All right, let's start with this question. We have uh, a simple statement where we should find out, with the help of this statement, we should find out what the logic gate is, and we need to draw the single logic gate for it.
Mm.
Okay, we have a certain situation over here to find out what the logic gate is. The only time the output will be 1 is when both inputs are 1.
That's the AND gate.
Perfect. That's and gate. So, and we know how to draw it, right?
Yeah,
Okay, let's move on to the next one. The only time the output will be 1 is when both inputs are 0.
that would be NAND.
That would be NAND. Let's write it. Oops.
The only time the
Right?
input our output would be one. Wait, the
Yes.
one.
So
That's NOR gate.
N NOR,
NOR gate. That's NOR gate.
NOR. That's not gate. Okay. Let's finalize it. If it is NOR or NAND or what, right? We have a certain situation which is A and a B with the 00, 11, and 01, 01. If it is NOR, not NAND, if it is NOR, then two zeros will become what?
1000.
So the only time one we have here in NOR, right? It
Mm.
says the only time the output will be 1. The only is, we have a stress on it. Okay, let's write NAND as well. Let's try it with the 1, which is we have 000 will become 1 in NAND. Yes. And this should
Mm.
be in AND, it should be 0, but we are going to write 1, 1, and then 0. So your answer is perfect over here. We don't have to write NAND, instead NOR. And it's like somewhat like this. I'm doing it very quickly, so it's not very good, but clear enough to understand. We have to place a bubble over here as well. The third one is the only time the output will be 0 is when the both input are 1.
That's NAND.
And output will be 0 when both inputs are 1. So we don't have to like now write it. The final one is, do we have a final one? No. All right. One more thing. No. This is known as building blocks, logic building blocks, logic gate building blocks. And as you can see, what is happening over here in this particular question, or probably the answer, not the question, they said we are going to construct AND gate with the help of two NAND gates. So are you getting it? What is happening over here? How it will react as a single AND gate. Basically, we have only two inputs, A and B, and we know that AND gate behavior is very simple. If we are like going to write AND, the AND behavior is 1, 0, 0, and 0. Is this correct? With the AND,
Yeah.
but if we are
Yeah.
going to write this circuit, let's find it out that what is happening. Now, here we have a NAND. So with the A and B, the first NAND we have, which is basically F according to the noting. So the NAND gate behavior, 00 will produce 1,
Mm.
1, 1, and 0. Is this correct?
Yeah.
Have I done within correctly? Now,
Yeah.
what is happening over here? This particular output is coming out from here and basically making this particular same output is splitted between two inputs, and we are sending it in one NAND, another NAND gate, right?
Okay.
So basically it is F and again F, right? Which is obviously
Yeah.
holding the same value. Now, two Fs are going inside a gate which is going to throw the output X. Now let's see if it is going to produce which type of a result. Now we are looking at 1, 1. If it is going inside a NAND gate, it will produce what?
If it's going in a NAND gate, so it'll be zero. Wait, NAND gate. So
Yes, 1 and
0,
1.
0,
This is 0. This will be 0, obviously. This will be 0,
and all ones,
and this is
and then the
1.
1. Yeah.
So basically, this particular statement, which we have output, and this particular statement with the X condition, both are same,
Mm.
right? So
Yeah.
basically, we are making a AND gate behavior with the help of two NAND gates,
Okay.
right?
Yeah.
What we have to do is to they would ask us to either simplify a NAND gate. Now, simplify simplify the gate. What they can throw as a question this particular thing and will ask us about that which single logic's gate will replace this particular statement. So if we don't probably don't remember the gates, what we can do something like this. To try it with either whatever the NAND or AND is, making the complete picture, and then we can find out which gate is this one. Going a little back again. Now, they said this is an OR gate. Now, is this going to work as an OR gate? Let's try to find out. Now we have again A and B, right? And as you can see that they are splitting the A over here and sending it in inside the NAND gate again, producing an F output. So A is going to be written as twice, B is going to be written as twice. So this is 00, 11, 00, 11 again, and 01, 01, and 01, and 01. Now we are going to produce F, which means the two zeros will become what in NAND?
In the NAND gate, the two zeros would be a one.
1. Great. Now this one,
One,
1,
zero, zero.
0, and 0. Again, if we are going to solve this G, so the output will be obviously
1010.
great. Now, as you can see that F and G are going inside an X. So this is our final output. What will be the result?
This would be 0, 1, 1 and 0. 1 and 1.
1 and 1. So if you are drawing a OR gate with the A and the B, again, if you would like to try with the A and the B and then X, we have so 00, 11, and 01 and 01 will become 00 will become 0. Otherwise, everything is 1. So now again, this statement and this statement is same. This means that yes, if we don't have, let's suppose I would like you to suppose for a while that the gates are physical components. And if we don't have OR gate, but we have multiple NAND gates together, forming it like this will have the behavior of OR gate and the vice versa, right? We have the final one, which is a NOT. Okay,
Yeah.
try it by yourself. Try it by yourself. Is this possible to make a NOT gate with the help of this?
So wouldn't
output of yes, 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 yes.
X would be 0? Wait, this is a NOT gate. Hold on. NOT gates are usually opposite.
Not this far opposite.
So it would be 1 and 0.
One, zero, zero, thinking.
It would be 1 and 0. 1, 0.
No, as if we can either send 0 or 1, right? Either 0 or 1. So if you're sending 0 or probably 1, the F is obviously split it with whatever the value you are sending, 0 or 1. So that's why I've written it again 0 and 1. Now, both are going, A and F are going inside NAND gate. So two zeros with the NAND will become,
Two zeros with an and will be 0.
oh, two zeros with the NAND will
Oh,
be
with an
0.
and or not?
No, no, this is NAND.
Oh, oh. Okay, then 1, then 1.
Yes. So this will be
And
1, this will be
0.
0. So if you are
Yeah.
sending, let's suppose 0 or 1, it is
It'd
going
be
to
1
invert it entirely and
into.
make make a NOT gate, right?
Okay.
So this is basically the behavior of NOT gate. So finally, we have the different logic gates. Okay, let me go for one of the question we have in the series, and I would like you to do certain things on it because people were quite surprised about this type of question. They said that the outputs were there at the very beginning. So we were quite surprised at how could the examiner is going to write the output. But yes, the outputs are there. And they ask us, there are 4 errors in the truth table. The output X column, identify the 4 incorrect outputs. And going, we need to write the entire raw as they have already given the raws.
So, like, we would have to solve the whole thing.
Yeah, we have to. But before we are going for it, we need to understand that what is the logic, basic logic of Boolean expression is. We can go for either directly with a Boolean expression. Can we solve it directly? Is there any possibility? Or we have to draw the entire circuit? What do you think?
So, I would do the whole thing, but there is possibly another way.
Means without,
Oh, the thing we did, the not plus the not one.
okay. Let me pause it a little bit and means I'm stopping this video for a while. Recording is related to related to the same item that there are some wrong inputs, and we need to, write the correct one. Means identifying the correct one, right? So we have three different type of questions in this document we have. All right. Now, what is your now? Here we have one type of question. Okay. Name the gate. One single logic gate. This is
That is
very,
the NOR gate.
this one is this one.
NOR. Wait, this is NAND.
This is nine. Yes, absolutely right. And just name it and draw the gate. So we'll get 2 marks. This is not. You
And
will
the
be
NOR gate.
absolutely double the yes. Right? So we have like sort of now, we are sort of good at this particular larger logic gate series, that yes, we can write it perfectly. What we are going to do is to conduct sort of a homework assignment. And in the homework assignment, it will be somewhat like this. So I'm staying over here, which is going to ask again that this is, and not asking for, not asking to draw it, just asking to for the either something is NAND or NOR or whatever, right?
Hmm.
Okay. So, but I believe that we need to close this chapter now. We have done a lot and now we are good at it, right? What about this one?
Okay. So we go step by step. So A or B,
Mm,
A or B, and B or not C.
perfect. So we'll get 3 marks for it. This simple line, right? Great. Good enough. Good enough. Okay, let's close this one. I'll obviously going to send the entire document to you for the practice, but this is enough for the logic gate and the circuits. Which chapter would you think that we should start now?
Sir, I would like prefer starting from the first chapter. Um, and that is the number system, the binary binary.
Yes, why not? Why not? Okay, this chapter is basically asking for multiple things. The data representation chapter, and let's begin with few very normal things, that is about how to identify or translate one number system with the other one, right? So the chapter is basically number systems. And if I have a number, let's suppose 25, you need to find out that this 25 can be either denary number and it can be hexadecimal until the base is going to appear, right? This can be written in hexadecimal as well if the base is 16. Are you getting the
Mm.
point?
Yeah.
And one number, very common number, 111, 111. 111. So this can be binary, denary, or hexadecimal as well,
Mm.
right? So we need to wait for what the base is, what the other word is, what the radix is, and then we can find out the treatment, what the treatment would be. Now, if I ask you to probably change this particular number 25, as this is a denary number, to denary to binary, what is uh, what your option is, how you're doing it?
So we would first write the whole like the numbers. I'm not sure what it's called, like, but like 1, 2, 4, 8,
Yeah.
16,
Right.
42, 64, and 128.
This is known as, when you are going to write 1, 2, 4, 8, 16, let's suppose 32, 64 till 128. This is known as binary notation table, right?
Oh,
This is known as binary notation table. And with this binary notation table, obviously, you would like to make 25 with the help of this. So this is a simple addition where I'm going to place 1 under 16. 16 plus 8 will become 24. And I need to go for 25. So let me open 1 or open the remaining item. The rest of the things are 0. This is binary 25, right? Is it okay? Or have I gone a little faster? What happened? Wait, I was asking about that. Is this okay? What do you think?
so what?
Wait. What is happening?